welcome to Ace with Ease. Today we're going to be looking at how to find an equation of a cubic function if we're given two x-intercepts, including one that is also a turning point and another point on the graph. Okay, so basically we have 3 points. You have two x-intercepts, including the one that is also a turning point and another point. Okay, so let's go right into it and look at the steps. So the first step would be to substitute the x-intercepts into the equation. Okay, y equals to a into x minus x1 all squared into x minus x2. Okay, so basically what we're saying is that in this first part here, you're going to substitute the x value that is an x, or the x-intercept that is also a turning point. Okay, and then on this other one you're gonna put the other x-intercept. Okay, so you just substitute them in there. Okay, and that will be all about it for the first step. Okay, and secondly, you're going to substitute the coordinates of the other point into the answer that you got in step 1. Okay, so after substituting the x-intercepts into this equation, you're just going to substitute the coordinates of the other point, okay, into the final answer, or to the answer that you got in step 1. Okay, and by so doing you will be able to solve for a, and you should solve for a. So after solving for a, you'll be done with step number 2. And after solving for a, you're going to substitute a and the x-intercepts, okay, which were given initially, okay, into that formula, okay, which is basically the same as the formula that you were given in the first equation. Okay, so you're gonna substitute your a and your x-intercept into the given formula, or into the standard formula, and then you're gonna simplify or expand. Okay, so let's have a look at a few examples. Okay, so if you look on your right, we've got two graphs. Okay, so they're both cubic graphs. Okay, so in the first example, our graph has got two turning points. Okay, so the first turning point is at x is equals to -3, and the next one is at x equals to 1. And we also have got another point, which is a y-intercept, which is at 0.3, and the coordinates of the y-intercept is 0 and 3. Okay, so what we need to do, we can see clearly that of the two x-intercepts, okay, one is the one that is also a turning point. Okay, so you can see that at this point the graph it touches the x-axis, and it's also a turning point. So we should be aware of that going into the first step. Okay, so what do we need to do? We have to substitute into the standard equation. Okay, the standard equation is y equals to a into x minus x1 all squared into x minus x2. Okay, so in this instance, you will in the first part we'll have to substitute the x-intercept that is also a turning point, which is obviously 1. That's why we have 1 there. Okay, and then the other x value we have to put it on the other side, but because it's negative, when we put it in, when we multiply it with the other negative that's inside the bracket, it will become positive. Okay, so this here will be the end of our first step. Okay, and then the next thing would be to substitute the coordinates of the other point on the graph. So the other point on the graph is 0 and 3. The coordinates of the other point on the graph is 0 and 3. So what we need to do is just to substitute. So basically we take the answer that we got in the previous step, and we substitute the coordinates of the other point on the graph. So the answer in question 1, or in step 1, was y equals to a into x minus 1 all squared into x plus 3. So which is what we have here. Okay, so we're just simply gonna take that answer, and we're gonna just substitute the values of the coordinates of the other point. Okay, so we'll just, where we see x we'll put 0, where we see y we'll put 3, and well, here we have for y we put 3, for x we put 0, and when we simplify we end up with a being 1. Okay, so after getting a, the last step would be to substitute the value of our a and our x-intercept into the the standard equation or the original equation. Okay, so here's our standard equation. We basically substituted the value of a. The value of a is 1, and then the x values we were given, it was 1 and -3, so we just substituted them. So we'll end up with y equals to open bracket x minus 1 all squared x minus x 2. Okay, so we substitute, and what am I saying? Excuse me. So yeah, if you substitute the a value and the x, and then in the x-intercepts, we'll end up with y equals to 1 into x minus 1 all squared into x plus 3. Okay, so we'll just have to expand. Okay, so in this case I'll start with a perfect square, but you can do it any way that is comfortable to you, as long as you know that you won't leave out any bracket, or you know that you won't make any mistakes. Okay, so I'll just expand the perfect square, and I'll end up with x squared minus 2x plus 1. Okay, and on the other bracket remains the same, so I'll just use the FOIL method, and I'll end up with x cubed plus 3x squared minus 2x squared minus 6x plus x plus 3. Okay, I'll just add the like terms, and my final answer will be x cubed plus x squared minus 5x plus 3. Okay, so that would be my final answer. Okay, I hope that makes sense. Okay, let's look at another example. Okay, so again we have got a cubic function that has got two x-intercepts. Okay, one of which is also a turning point. Okay, so we'll use that formula again for that standard equation. Okay, and in the first part where there's a squared, we're going to substitute the x value, that is also a turning, the x-intercept, that is also a turning point. Okay, so in this instance, the x-intercept that is also a turning point is -2. So if we substitute -2 into that, we'll end up with +2, because there's going to be negative times negative, which is going to give us positive. So we'll have y equals to a into x plus 2 all squared. Okay, and then the 1, when you substitute it there, is going to just remain the same. So it means at the end of step 1, we'll have y equals to a into x plus 2 all squared into x minus 1. Okay, so that would be the end of step 1. And for step 2, what we need to do is to substitute another point from the graph. So if you look at that graph very well, you will see that we are given a point b is -1, and the x value at b is -1, and the y value is -4. So we simply substitute. Okay, and when we substitute, we get a to be 2. Okay, and we substitute and solve for a, and we find a to be 2. Okay, and from there we'll substitute the x value, the x values or the x-intercepts into the original equation, and the value of a, okay, into the original equation, and we'll end up with an answer of y equals to 2x cubed plus 6x minus 8. Okay, I hope that makes sense, guys. Thank you for watching, and if you have not subscribed, please subscribe, and let's meet in the next video. Thank you.